What is 1/1,000,000th of a mouthwash? It's a microscope. Microscope. Anyways, today we will be converting not mouthwash, but units, and we will also be dealing with dimensional change and its impact on perimeter, area, and volume. So first of all, I have a small typo on this page, or a big typo, depending on how you look at it. That's not supposed to be perimeter. That is supposed to be volume. So one of the ways that you all will choose to do converting and dimensional change is a lot of times you're going to pick the long way to do it. You're going to say, well, let me just go ahead and find the area using the original value. So you're going to go ahead and find that out, original, and then you can find the area, or maybe it's the perimeter of the volume, with the new value, and then make a ratio to see the effect. And this always, always, always works, but it's a lot more work than some of the other methods. So I'm going to show you some times where it's a lot simpler just to look at the factor and see its impact. So one of the ways it's a lot simpler is converting units. So a lot of times you've seen problems where you had to calculate, say, the square feet. And then we said, oh, if a foot is X meters, then how could you find the area in meters squared? Well, the way that you can do this, if you're going to do a conversion factor, is you want to make a ratio of the new units. So if you're changing to meters, that would go on top, over the old units. And if that was feet, that would go on bottom. The exponent on the scale factor depends on the number of dimensions. Dimensions, D-I-M-E-N-S-I-O-N-S. All right, dimensions. So one-dimensional, two-dimensional, or three-dimensional. Perimeter is one-dimensional. So all you have to do is multiply by the factor to the first power, or just the factor. Because factor to the first power is the same thing as the factor. You can write CF, or conversion factor. If you're dealing with area, that's two-dimensional. So the exponent on the factor would be 2, which is the factor squared. If you're dealing with volume, that's 3 dimensions. So that would be the factor cubed. And I'll show you some examples of how you would be applying conversion units. In example 1, given that 1 foot equals 0.3048 meters, or 3,048 10,000ths of a meter, complete the table to the nearest hundredth for a prism. So it's not really important when converting to know what the actual shape is. I did make these so they were all consistent. It really does work, but I could have made some numbers and just put them in there. And all you had to do is apply the factor onto it. So the factor, the new units that we're changing to are meters. So the meters number goes on top, 0.3048 meters over 1 foot. That's the ratio I'll use. And I'm going to take that and I'm going to multiply it by 8 feet. And when I do that, I will get and since I'm going to the hundredths, 2.44, pretend that's a 2.44 meters. All right. All I did was multiply that by the conversion factor, which was the 0.3048 over the 1 foot to the first power. And that should really be a decimal. There we go. All right. Now, if I'm going to do this for the surface area, what I'm going to do is do the 0.3048, but instead of having it to the first power, I'm going to have it squared, and I'm going to multiply it by the 24. So when I multiply it by the 24, I get 2.23 meters squared. When I do volume, all I have to do is multiply the volume by this ratio. There we go, cubed. So times 16. And then my number will actually get even smaller. It'll be 45 hundredths of a meter cubed, or of a cubic meter. Okay, so I use the same number, 0.3048, and I just said 0.3048 instead of 0.3048 over 1, because when you divide by 1, you get the same number. So I just take that number and put an exponent on it according to the dimensions. In example 2, it's a little different. Given that 1 kilometer equals 1 mile, 1 kilometer equals 0.6214 miles. I've got more typos on this notes than I'm used to. Complete the table to the nearest hundredth for a lake, and I'm talking about an actual body of body of water. So the factor will be 1 mile, because that's the new unit. That's actually, the factor will be 1 kilometer, all over the number of miles, 0.6214. And I want kilometers on top because that's the units I'm changing to. So that's the factor. When I use my calculator, I find out this is the same as 1.609. So 1.609 kilometers, 2 miles. So if I multiply this by 10, that's just moving the decimal over one place, and I'm going to get 16.09 kilometers. To convert surface area, I'm going to have to multiply the 6 times 1.609. Now this is a two-dimensional value, so I need to square the 1.609. And when I go ahead and multiply that all out, I'm going to get 15 and 55 hundredths of kilometers squared. For volume, I'm going to take 18 times, and since volume is three-dimensional, I multiply it by that factor cubed, and I will get 74 and 98 hundredths of cubic kilometers. Okay, so perimeter, exponent's 1. Area, exponent is 2. Volume, exponent is 3 on the conversion factor. Conversion factor is always made by putting the new units over the old units, and usually they'll give you that information in the problem. Now, changing all 3 dimensions, like applying a scale factor like we learned at the beginning of this semester, it's very similar to doing a conversion factor. So, and if the factor is not given, you can find it. The way we did it is we said we took the new dimension or the new value, I'm going to say dimension, over the old dimension. A lot of times I've noticed on the problems we tend to give you the scale factor, but if we don't, if we gave you like the length is this in one problem and then it switches to another number in another problem, you can calculate the scale factor. The effects are similar to converting, so the exponent is also dependent on the number of dimensions. So the number of dimensions has not changed. Perimeter is still considered one-dimensional. Area is considered two-dimensional, and volume is three-dimensional. So if I'm trying to find the new perimeter with a scale factor, I just multiply by the scale factor. All right. If it's a new area, I actually have to multiply by the scale factor squared. If it's a new volume, I have to multiply by the scale factor cubed. Now, changing a radius or a diameter, by the way, on a sphere will always change all 3 dimensions. If it doesn't change all 3 dimensions, it's no longer a sphere. So changing a radius or a diameter is basically like doing a scale factor. So kind of be thankful if you're dealing with a sphere, that those are the easiest problems. So let's look at example 3. So if I'm doubling the diameter of a sphere, then perimeter is one-dimensional. So I will go times 2. So it'll be the old perimeter, pretend that's a P, times 2. If I'm doing area, I'm going to go area times 2 squared, which is area times 4, to get my new area. If I'm doing volume, it's going to be volume times 2 cubed. 2 times 2 times 2 is 8. So I could just multiply the volume by 8. If I triple each side of a hexagonal prism, so That means I'm changing all the dimensions. It may not be especially clear there, but that's what I meant. So I will go perimeter times 3, area times 3 squared, or area times 9. Volume times 3 cubed, or volume times 27. What if I divide the radius of a sphere by 4? Remember, radius also affects all 3 dimensions. So I'm going to say the circumference, which is the perimeter, that's one-dimensional. I just divide by 4 to the first power, which is 4. If I'm dealing with the area, I'm going to divide by 4 squared, which is the same thing as dividing by 16. If I'm dealing with volume, I'm going to divide. Now, notice I'm dividing all the time here. If it's a division here to the dimension, it's going to be a division on all the values. So on volume, I'll divide by 4, but to the third power, which is 64. So volume divided by 64 gives me my new volume. What if I multiply each side of a pyramid by 2/3? Well, for my perimeter, I would just multiply by 2/3, just like we did to the sides. For my area, I'll multiply by 2/3 squared. And you're going to square the top and the bottom. So it's area times 4 over 9. If I'm dealing with volume, it'll be volume times 2/3 to the third power. And the 2 is cubed and the 3 is cubed. So it's volume times 8 over 27. If I'm cutting the radius in half, that means that my perimeter, the distance around the circle, will be half as much. So I could say circumference or perimeter. They're both kind of the same idea. I would divide it by 2. The area of my circle would be divided by, area is 2-dimensional, so it'd be 2 squared, or just divide by 4. Volume would be divided by 2 cubed. So volume is divided by 8. Now, if you'd wanted to, say, cut the radius in half, you could have said multiply by half for circumference, multiply by half squared or a fourth for area, or multiply by half cubed for volume. But I know it feels more natural to you to divide, and I would accept these as answers because they will give me the right answer. So again, since we cut the radius in half, we diminish the size, we're dividing everything by the scale factor with a proper exponent. Perimeter's exponent is 1, area exponent is 2, volume exponent is 3. If I increase all dimensions of a nonagonal pyramid, I can normally say it, by a factor of 5, then what is the effect? So I would multiply the perimeter by 5 to the first power, which is just 5. The area would increase by 5 squared, or 25. The volume would increase by 5 cubed, or 125. And then last but not least, the sides of a cube change from 4 centimeters to 12 centimeters. So this one I gave to you so you could actually figure out the scale factor yourself. Now put the new one over the old one. So 12 divided by 4, that's 3. So my scale factor is 3. Perimeter times 3, area times 3 squared, or 9. And volume times 3 cubed, or volume times 27. So scale factor problems are really very simple if you know the scale factor. And they're a lot like the converting units problems.